So before moving forward in the video, I have an important announcement for you. So if you're somebody who is actually willing to learn advanced backend technologies, then this is going to be the right platform for you. So at Algocamp, we have launched our new flagship Lambda 4.0 Advanced Live Backend Development Batch, in which you are going to learn advanced backend technologies including Fastify, Express.js, AWS, Mongo, DynamoDB and whatnot. This is going to be a power-packed course in which we are going to take you from the very scratch, very basics of backend technologies to the very advanced level by building a lot of interesting projects. We are going to build projects like Code Sandbox Clone. We are going to build streaming app which will include recorded movie streaming plus live streaming as well. We are going to make applications like booking.com backend, which is going to help you understand transactional capabilities, integrations of payment gateways and many more. All the important projects that we are going to cover in the course is going to be listed here, and this is going to be an absolute live course where we are going to take live classes, right? And in these live classes we are going to do hands-on coding experience to learn all the important advanced backend technologies. You already know that backend is something that every important application needs, and you can actually excel your software engineering career with these backend tech in the Node.js stack. So what are you waiting for? All the important links, the complete syllabus, curriculum, all the details of the course is present in the description section below. You can use the coupon code coming up here to get maximum discount off on the current price. I'm really excited for the course. I hope you guys are too. And now let's get back to the video. So we are now going to code a snake game, and let me help you with the basic constructs of a snake game, right? So these kind of snake games used to exist in kind of like Nokia phones and like a Google game as well. If you want to play this on Google, in case if you don't know how to play this on Google, just write snake game and this Google game will occur, and you can see, you can click on play, and the main core functionality in the snake game is that so with the arrow keys you can actually move your snake in up, left, right, down direction, right? The moment, and there are food coming up in your arena, right? You have to actually eat the food. When you eat the food, the snake grows and the score improves. In case the snake collides with the boundary, then the game is over, right? You can add more rules and everything, but let's go with the basic construct that let's say there is kind of like a arena region that you will be having. Okay, inside this arena region you will be having a snake. Okay, you will be having a snake, and there will be some food item. If the snake eats this food item, then there will be a score that we are going to represent. We are going to increment the score, and there should be a start stop button to start a game and stop the game, kind of like this. This kind of functionality we actually need, right? And this is something that we are going to also focus on, right? So now let's see what are some of the, I would say, core aspects of the game that we have to keep in mind. So first of all, let's try to see that what all things or like entities are there in our code. Definitely there's a snake, there's a food item. This food item is going to be, every time when the snake eats it, this food item is going to come up again somewhere else, right? So it will be randomly placed inside your game region. It will be randomly placed inside your game region. Okay, cool. We have to see how can we implement snake. Score is very easily implementable. I guess you can keep a score variable and keep on incrementing the score when the snake eats the food. How can you mimic the snake eating of snake, like snake eating the food? How can you mimic that? So you can actually see that if let's say this is a div and this is a div, you can actually see the collision of the divs at any point of time. Let's say if this snake div collides with this circular div, right? That is, the left boundary of the circle is going beyond the right boundary of this snake. That means the snake has completely consumed the food item. Okay, this is going to be there, and we need to support the up arrow key, down arrow key, right arrow key and left arrow key so that we can give the directions. Okay, this is going to be something that we have to always keep in mind, right? So now what we have to try to understand is that how to mimic all of this. To be very honest, preparing this boundary, preparing this food items is not going to be that much of a difficulty, right? The only thing here is that how you are going to represent the snake, how we are going to represent the snake. Because the thing is that the moment snake eats the food, then technically what should happen is the snake needs to grow as well. That is a very interesting perspective, right? That the moment snake eats the food, let's say if it was of 3 unit length, then the length is going to actually increase as well, right? The length is going to actually increase as well, right? So this is something that you have to kind of like keep in mind, that this snake needs to be represented in a form of a data structure that is growable. Like you are able to add something to it. Let's say there are let's say there is a snake of length 3 units, right? You should be able to increase the length of the snake somehow. Somehow you should be able to do it, right? Now, what is a good way to represent this kind of a structure? What is a good way to represent this kind of a structure which can grow incrementally whenever we want? How about in a simple term, we can keep an array to represent the snake. How about that? We can keep an array to represent the snake. But there is more complexity with the snake. What is the more complexity with the snake? At some point of time, while moving, snake might be in this kind of an orientation as well. Like let's say snake was moving in this direction and I press the downwards key. So snake will start moving in this direction, right? So there can be a case that snake is in this kind of an orientation. How can we actually handle this kind of an orientation, right? So what we can actually do is, at any point of time, the array of snake will be of a certain length n, and each entry inside this array is going to represent a kind of like a coordinate, right? So of course you can actually divide your grid in kind of like coordinates, right? Like you can actually divide your grid in kind of like coordinates. So every time, let's say currently if the snake is moving straight, then there are these, let's say 4 coordinates that the snake is consuming. When the snake moves ahead, then this coordinate will go and this coordinate will come up. Think about it like this. Think about it like this. So let's say if we have a 2D grid. Let's say we have a 2D grid. Okay. Just a moment. Sorry. Right. Just like this, we have a 2D grid, right? So we can represent our coordinates in the form of a 2D grid. So let's say at some point of time, this region, and this region, this is representing the snake. Let's say our snake is at this position. Then let's say in the next second, the scale, whatever was the original direction of snake, it will keep on moving that. So let's say this is the direction of the snake. Now the snake has to move here, but it has not ate anything, right? It didn't eat anything. So the size should remain 3. But how the snake moves here? So we can mimic the movement of snake by making sure that we remove this cell from the snake and we add, let's say, this particular cell. So if let's say every cell has a coordinate, So inside my array initially, let's say we were having x1, y1, x2, y2, x3, y3. This was, let's say, this state. Now let's say if I want to move right, what will happen is we are going to remove x1, y1, right? We are going to remove x1, y1, and let's say we are going to add x4, y4. Then what will happen? This x1, y1 will be removed and x4, y4 will be added. So at every point of time, this array is going to represent the coordinates at which the snake is. If let's say the snake makes a move here, right? The snake starts moving here. Then in that case, again, what will happen is we will remove x2, y2. x2, y2 gets removed, and we are going to add this one. Let's say this is x5, y5. Okay. So let's say this is x5, y5. Okay, like this. So you can see this is the movement that we can go. Then again, let's say snake moves forward, so we can remove again x3, y3, and let's say in place of that x3, y3, we can add x5, y5. So let's say this is x5, y5, right? So very easily we'll be able to make the movement of snake like this, right? So we are going to have an array of coordinates. This will be an array of coordinates that we can actually use to represent the snake. Fun fact, in one of the Apple interviews for full stack engineer role. In one of the coding rounds, I was asked, not in JavaScript ideally, but I was asked to code a snake game, kind of like machine coding round. I was asked, and a similar solution I implemented there as well, that we can have an array of coordinates. Every time this array is going to store some coordinates. Now, because we are using JavaScript and HTML and everything, what we can actually do is every time, whatever are the number of coordinates that are stored in the array, right? We are going to just keep on coloring those coordinates. We will keep those coordinates colored so that we can represent the snake. As simple as that. So this kind of an architecture we can actually have. Otherwise, collision is going to be pretty much simple, that if the coordinates like of the head, like the first cell clashes with the coordinate of this particular food item, then we can assume that snake has consumed this food item, and we can increase the length of the snake. When we increase the length of the snake, then what will happen is you are not going to remove anything from the last. You're going to just add something at the top, right? You should not remove anything from the last. Then one aspect is to add event listener. One aspect is going to be to add event listener for the click event of these 4 buttons specifically. There will be one score that we can maintain. This is going to be pretty simple, right? And then there should be a start stop game. When you do a start game, the whole game should actually reset itself and start from a new state. These are going to be some things that we are going to keep in mind. So there must be a question coming to your mind, that if we have to detect a situation that snake actually hits itself, how can you do that? If the head of the snake is at a coordinate which is already inside the array, right? You can check, right, that you can search inside your whole array, that if there is one coordinate that is present twice, that means there is a cycle. If there is a cycle of the snake, that means snake has collided with itself, kind of like that. Now, in order to build our game, we need 1 or 3 4 basic things. Okay, let's first of all set up our basic HTML. Okay, now what we are going to do is we are going to have a very simple div with an ID as game arena. Okay, this will be the region of the game that we are going to actually control. Then there should be a script.js file, and we should technically add that script here. So script source script.js, save it. Inside the script.js, I'll say console.log script working, save it. I'll turn up the live server and I'll open it in Chrome. And I'll inspect. And if you go to console, you can see script working, no problem, right? You can see script working. So we are able to connect our HTML file to our JavaScript code. Okay, this definitely looks a bit good to me. Cool. I'll prepare a very basic CSS as well, right? We are not going to focus a lot on the CSS, but still bare minimum CSS we are going to have. Okay. So in the body, I'll keep the whole body as display flex. Again, as I said, this project is not going to make sure that you know very well CSS and everything. This is to make sure that you do a hands-on with JavaScript. Okay. Flex direction I'm going to keep as column. So there will be a bunch of items. For example, there will be a score, there will be a start stop button, there will be actual game region. Everything we are going to keep in kind of like the body. I'll say align items as center. Okay. And justify content as center. This is good. And I'll say the height of the body should be 100 viewport height, right? And let's say we'll keep the background color as something like antique white. Okay, cool. And all of the text is going to align at center. Save it. Okay. And currently this style.css is not linked to our index.html. So let's do that. So link CSS style.css, document should be snake game, title should be snake game, and you can see very basic color is in the place, right? This looks good. Now we have a game area or game arena. Let's try to style this game arena so that we can specifically see it. Game arena. Okay, so we will give it a particular width and height. So let's say 400 pixel, let's say width, and let's say height we are also going to give 400 pixels. Let's have a square grid as the arena, right? Background color we are going to keep, let's say kind of like grayish blackish. Okay, Then we'll give position relative. Okay, we'll give it a border, slightly thick border, just like the Google game was having. So let's say 5 pixel solid, slightly more lighter gray we are going to give. Margin from the bottom we are going to have as, let's say, 20 pixels. And let's say we'll give it a box shadow. So box shadow we are going to give 0 0 20 pixels RGBA. Okay, something like this. If you refresh, you can see kind of like a small game arena we have. We can expand it, I believe. So let's say, how about if we do 600 pixels, 600 pixels. Yeah, and I believe we should keep it a bit more wide. So maybe 750 pixels or 800. So yeah, this should be our main game arena that we are going to have. So the snake is going to actually move inside this place altogether, right? I believe this is now in a good shape. This is the bare minimum HTML and CSS that we definitely need. So basic styling added. Here we go. So what we are going to do is we are going to say document dot add event listener DOM content loaded. So once the whole DOM content is loaded, then we are going to execute the script. So first thing first, we need to have some variables so that we can actually manage the whole game. Let's say we need to have a global snake kind of a thing, because that will be controlled everywhere. We need just one snake. There will be a food variable that we can keep, because that will be just randomly moving here and there. There will be this game area. There will be a score variable. All of these, let's say, kind of like global variables we need. So I'll say game arena is equals to document dot get element by ID game arena. Okay, so we have the game arena in front of us. Can I say that? Okay, and let's say we are going to keep a game size, and let's do one thing. Let's, for simplicity, let's make both of them 800 pixels, or let's say 600 should be fine for now. I'll tell you how you can modify it, but for the timing, let's keep both of them 600 for simplicity. I'm doing. So what I'll do is I'll say const arena size is equals to 600. Okay, cool. Now every cell, now I assumed, right, that we are going to have a kind of like a 2D grid. So every cell of this 2D grid, what we are going to do, we are going to assume it of, let's say, kind of like 20 pixel size. So I'll say cell size is equals to 20. Okay, then we are going to have a score. So let's say let score, we cannot keep it const because the score is going to change. Let game started is equals to false. So initially game started is going to be false, because when we will press a particular button, then only the game will actually start. Okay, then we are going to have kind of like a food variable. Let food is equals to, so food is just going to be an object which is going to be at some particular coordinate. Let's say initially the coordinate is at x 300 by 200. Okay, something like this is going to be our food. Then we need our snake, and as I mentioned, snake is going to be an array. This is going to be an array of coordinates, right? So let's say by default we are going to have snake of length 3, which will be at some initial coordinates. So let's put these coordinates like 160 by 200, and let's say we want it horizontal, right? So let's say the next coordinate will be this should be 160. Okay, so if x-axis 160, then the next coordinate we should keep at 140, right? Because we want 20 unit cell. If you want one cell to be 20 unit, then 160, then 140, y remains 200, and let's say 120, and y remains 200, because we are going to keep every cell of size 20. So think about it like this: the y coordinate is all constant, right? So y axis is going to be same, x is changing. So one cell is at x is equals to 160, one cell is at x is equals to 140, one cell is at x is equals to 120. Why there's a 20 20 20 unit gap? Because each cell is of length 20. So if you want to keep 3 consecutive cells starting from 120, let's say, so it should be 120 140 160, right? 20 20 unit gap should be present there. This is something that is very important that you should keep in mind. So technically, if I draw it, you can say that this is a cell, and for us, size is 20 units. So inside this cell, there will be multiple pixels, right? So 20 pixels length, 20 pixel height will together make one total cell, right? This is something that you have to keep in mind. So previously we already prepared a game that was the ping pong game, right? In that game, we realized one simple thing, that if we have a moving object in physics, at any point of time, if you have a moving object, then every moving object should possess one simple property. What simple property that they should possess is that in which direction they are moving, they should be explicit with that. Okay. So let's say we have a snake here. Let's say we have a snake here. And let's say this is moving in the positive x-axis direction, right? This is moving in the positive x-axis direction. If it is moving positive x-axis direction, then in every move, what we want is it should move with at least 20 pixel, right? Every time it should move 20 pixel ahead, because if it will move 20 pixel ahead, it will give us a feeling like this, that it came here, right? Just think about it. If every time we keep on incrementing the coordinates by 20 pixel, for example, let's say this is x is equals to 120, this is x is equals to 140, this is x is equals to 160. Now we want to move ahead. How about we remove the entry of x 120 y 200 and add an entry of x 180 y 200. So this will look like the snake came here, right? Okay. So every time I am adding 20 units, every time I am adding 20 units. So can I say the displacement on the x-axis is going to be plus 20 if we are moving in the right side? Think about if we are moving in the left side, like let's say the snake is coming in this direction, and this is, let's say, 120, 140, 160. Then what will happen is you're going to remove this and you're going to add x is equals to 100, y is equals to 200. You are going to add it like this. So you're going to decrease by 20. So if you are move in positive x direction, then dx will be plus 20. Otherwise, dx is going to be minus 20. Can I say that? If you are going to move in negative x direction. This is something that you have to keep in mind. And this sign is going to actually help us to do that, because plus 20 means that you are adding, that means you are going to the right side. Minus 20 means you are subtracting, that means you are going to the left side. This is a very important aspect of the game, right? This is a very, very important aspect of the game. You cannot actually play a lot with it, because direction along with the speed. So technically here this speed unit is 20, that you are always displacing by 20 units. And that makes sense, right? We always want to move 20 units from here to here. This is something that is very crucial, right? And similar kind of a structure we are going to have in y. But initially you can see there is no displacement in y, right? Initially there can be a case that the snake is moving in this direction. Now there is no displacement in y, right? So initially we can keep dy as 0. But just think about it like this. If let's say the snake is in this direction, like this is our snake, let's say this is our snake, and snake is moving in this direction. Now in this case, what you're doing, you're vertically moving. Your x-axis doesn't move. Your x-axis doesn't move. You are vertically moving. When you are vertically moving, then dx should be 0. When you're horizontally moving, then dy should be 0. So this should be 0 in horizontal movement. And dx should be 0 in vertical movement. I hope this point is making sense to everyone. When you are moving vertical, then your x coordinate remains same. Whatever was the x coordinate, it still is the same x coordinate. Only y coordinate is changing. When you're moving horizontally, y coordinate remains same. Otherwise, they are going to change like this. Just like how dx changed, dy is also going to change with the 20 units. If you are going up, then this is plus of 20 units in dy. If you are going down, then it is minus of 20 units in dy. Things like that. This is how we are going to give the directions to our application, right? So we need two variables, dx and dy. Let dx is equals to 20 and let dy is equals to 0. And instead of 20, let's keep it of cell size. Okay. So this is going to represent displacement on x-axis. This is going to represent displacement on y-axis. This is very crucial. Now what we are going to do, we are going to draw a few things on our, let's say, game arena as well, right? So generally it makes sense to keep a draw function separately, because every time we have to draw, like whenever the snake will move, no, we need to redraw the snake, because when the snake will move, the coordinates of the snake will move. So we might have to create a bunch of new divs and remove the old divs altogether, right? This is something that we might have to do. So let's do one thing. Let's say, we have kind of like a function start game. And what we are going to do, we are going to eventually call this start game method. Okay. Start game is going to initialize the whole game for us. Okay, cool. So to initialize the whole game, what you can actually do is you can keep a score element as well, right? So you can have a score div coming up here, or you can separately on the go make a score div as well. So I'll make it on the go. So I'll say scoreboard is equals to, so how do you make a div directly by JavaScript? Very easy. Document dot create element div. Okay, right? We'll say scoreboard dot id is equals to scoreboard, right? And let's say we are going to have a scoreboard coming up here, let's say, right? So we'll style the scoreboard, but we'll style it in a moment. So we'll be having a scoreboard id, right? And then what we can do is we can actually say, let's say, document dot body dot insert. So there is a method called as insert before, right? What we are going to do, we are going to insert scoreboard before the game arena. If I, let's say, save it, and let's do also one thing. We'll say scoreboard dot text content is equals to, let's say, 10 for a moment. 10. Can you see there is a small scoreboard actually coming up, right? Small scoreboard coming up. Let's give it a good styling so that we can actually see the scoreboard in action, right? So let's say we'll give it a font size, let's say extra large, right? And let's say we'll give it a color. What will look good on this antique white? I believe cornflower blue will look good, maybe. And let's say we'll give it a margin of 10 pixels, 0. Save it. Can you see this is the score, right? We can give a font weight of bold, right? Cornflower blue doesn't look good to me. Maybe we can keep it a black. Yeah, score is coming as 10 here, right? So this will be kind of like the scoreboard that we actually need, right? So this looks good, this looks good. Basic, we just created an element, right? And this element will not be created till the time we don't actually start the game. Like, you will see why I have done something like that. Okay, so now what we are actually going to do, initially the scoreboard will be having no text content. The moment you remove the scoreboard text content, you can see it is gone. Text content should actually start coming up when the game actually starts. Okay, then what we are going to do is we are going to have a button as well. Like button, I can maybe directly okay, button also we want to control with JavaScript only. So let's say we'll have a start button, document dot create element button. And definitely instead of making it with JavaScript, you can make it with HTML directly and handle the styling. That, let's say, the block is none for button and the scoreboard. You can even do that. Like, multiple approaches can be there to do the same thing. Okay, we can say start button dot text content is equals to start game. Okay, and let's say start button dot, let's say, class list dot add start button. So we're going to style this start button. Okay, and we can say document dot body dot append child start button, right? Let's style this start button. Let's style this start button. Okay, cool. Very simple to style the start button, right? So let's do something like this. So if you see, there's a start button coming up. First of all, let's give it a background color. So let's say background color is something like
very bad. Color choice is difficult. Orange, red. Yep, okay. Still looking better. Cool. Then text color we can keep white. Okay. Padding we can give 15 pixels and 30 pixels. Save it. You can see looking good. Then let's say text align center, right? And text decoration we'll do none. Okay. And font size we can increase. Font size should be, let's say, 18 pixels. Yep, bigger, better. Okay. And we'll give it a margin, top and bottom 4 pixels. Looks good. And let's see, we'll change the cursor to pointer and border to none, right? And we'll give it a border radius of, let's say, 6 pixels. Yeah. Start button game actually is coming in shape, right? So you can see this definitely looks good. We can commit up till now. We can commit everything up till now. Added scoreboard and start button. Here we go. So now what we want is the moment user clicks on the start button, we want to start the game. Before the start button is not pressed, we don't want to start the game. Okay. And you can see this start game function is called the moment DOM content is completely loaded. This callback will be executed, and the first function of this callback is start game. So technically, this is the first function to be executed so that we prepare the UI. Now, the moment somebody clicks this start button, so I'll say start button dot add event listener click. Now, when somebody clicks the start game button, now when I click this button, what I want is then the game should technically start. Can I say that? Then actually the game should start. So if the game is going to start, what we should do is we should say start button dot display, right? Sorry, start button dot style dot display as none, right? And let's say there will be a run game method that we are going to call. Let's say we are going to write a function run game. Can I say that? Now the actual game is also now going to start. Okay. Or this should be, instead of start game, we should call initiate game. That should be a bit better naming convention. Initiate game. And run game should actually start running the game. Right. Now, how should you start running the game? You have to first of all check. You can see this is a variable game started. So first thing that you should do is we should say game started is equals to true, right? And now what we should do is we should start running kind of like a loop, because we need to bring snake onto the arena and keep on moving the snake. So even if I don't press a key and there is already a direction given to the snake should keep on moving in that direction. So this should happen again and again and again. So we need kind of like re-rendering of the whole DOM tree. So I'll write a function game loop. Inside the function game loop, what we can have is we can have kind of like a set interval, right? Or let's say we can have like kind of like a set timeout for a moment. Let's say we have a set timeout. Okay. And let's say there is a timeout of 1 second. Okay. Inside this set timeout, what we should do is that after 1 second, we should first of all draw our snake, draw our score, and then rerun, let's say, this game loop. Or you can also do it in a kind of like a set interval altogether, right? So let's do it maybe in a set interval. Okay. So every 1 second we are going to actually draw something, change something, and do something. Okay. This is what we have to do. So first thing first that we will do is draw scoreboard. So we will be having a method draw scoreboard. Let's implement this draw scoreboard. Function draw scoreboard. Okay. how we should draw the scoreboard. So technically we should get the scoreboard here, right? ID is scoreboard. So I'll say const scoreboard is equals to document dot get element by ID scoreboard. We'll get the scoreboard, okay? And we'll say that scoreboard dot inner HTML, let's say how should we write? Text content, let's use text content is equals to, we'll write a text content as score dollar, and we'll use the score variable. We will use the score variable here. And yeah, let's save it. So now if I click on start game, can you see score comes into the place? Score comes into the place. Okay, so it has started an interval. You can see if I click on start game, it starts, score is equals to 0. Okay, this looks good. Now similarly, how it draw score, we need to also draw our snake. Can I say that? Just like how it draw the score, we need to draw our snake, and we need to actually draw the food item also. Food item is still not drawn. We need to draw the food item also. So let's maybe call that. So let's say draw food and snake. Okay. And I'm segregating this in separate functions so that we can keep the code clean and modular, so that any point of time we need specific thing from a function, we can just update that. So draw food and snake. Now, how will you draw your food and snake? Okay. First thing first, we'll say game arena dot inner HTML is equals to empty. If let's say previously something is drawn, if previously something is drawn, remove it. Right? Because let's say your snake was inside this region. Now what do you need to do is you need to move the snake so that this moves here and here. So first of all, what you have to do is you have to clean the whole game arena and then redraw these 3 cells. That's how things will work, right? It will not just redraw one particular cell. Otherwise, you have to write a very complex algorithm that, okay, this particular cell should get vanished and this particular cell should go there. Instead, what we can do is we can wipe out everything and redraw with the new coordinates. So what we'll do is we'll wipe out everything and redraw with new coordinates when snake moves. Okay. This is the strategy that we are going to keep. Okay. So first of all, let's prepare a new food item. Okay. Okay. So now the thing is that we'll say const food element is equals to. Now, can you say that there will be an array of snake? There will be an array of snake for which we have to draw divs, right? See, there will be coordinates, right? This is going to be a coordinate in the array. This is going to be a coordinate in the array. This is going to be a coordinate in the array. So we have to make div here. We have to draw a div here. We have to draw a div here. Then we have to draw a div of the food item also. So we have to draw multiple divs multiple times. Can I say that? And all of these divs are going to be of width 20, right? So let's try to do something like this. So maybe we can have a common function, draw div. Okay, we are going to have a common function, draw div. Okay, this draw div method is going to take, let's say, a x coordinate, y coordinate, and the class name, because snake will be giving a different class name and food item will be giving a different class name. What we'll do is we'll create a div document.create element div, and then we can say div dot class list dot add class name. We'll add the class name, and then we'll say div dot style dot top is equals to, what should be the top? X pixels, and div dot style dot left should be y pixel. Okay, and then we can return the div. So this function is going to be a common function that can draw a div for us, right? With the top and the left coordinate given as this, right? So what we are going to do is we are going to say create div or draw div. The coordinates are going to be food.x, food.y, and class name will be food. And what we can do is we can say game arena dot append child food element. Okay, this looks interesting. If I save it, you can see nothing will happen. Why? Because we have not styled our food. We need to style the food, right? So let's try to style the food. And you're saying top should be this, right? So technically, top should be y pixels and left should be x pixels. That should be a correction, right? Now let's try to style our food. So we have given a class food. So dot food. Sorry. Dot food. Okay. We'll style the food very easily. So let's say, because width is going to be 20 pixel, because every cell is expected to be of 20 pixel, right? So width and height should be of 20 pixels. Let's say background color, let's say is going to be red. Okay. Position is going to be absolute. Why absolute? Because the parent div, who is the parent div? Game arena. If you see, game arena has a position relative. So it will be absolute with respect to the relative parent, right? That's why we have given top and left property. This top and left property will work if and only if we have absolute here, right? Then let's say border radius 50%, right? And let's do one thing. Yeah, let's have it like this. Save it, refresh, and if I click on start game, can you see there is a small dot coming up? There is a small dot coming up. This definitely looks nice. This definitely looks nice. Okay, we can add a very small you can say animation, right? So we can add a keyframe, right? Blink. Okay, and we can play with the opacity. So at 50%, the opacity should be 0.5, and we can say animation, we can add blink animation. It should every time go for, let's say, 1 second and for infinite time. Save it. Can you see there is a blinking animation coming up? Right, this looks nice. This definitely looks nice. I can zoom in a bit. Right, so there is a blinking animation coming up so that the snake can actually go towards it. This gives a good feeling. So I'll commit up till now, commit everything up till now. So what we have actually achieved: added food item in the game area, game arena. There we go. Now in the similar way, how we created our food, we can also create the snake. So first of all, let's give a snake class some shape so that we can look at snake being drawn. Again, same thing, width and height should be 20 pixels. So I'll keep that here. Okay. Background color for the snake, I want it to be kind of like greenish. Let's say chart reuse. Okay. And let's say position is absolute. Okay. Same thing like food. And the border radius, I want slight border radius. So let's say 5 pixels. Save it. Okay. Currently you can see nothing is drawn here, but what we can do is, in the same function where we are drawing the food, we should draw the snake also. How can we draw the snake? Now you can see, if you want to draw the snake, you need to draw divs at this cell, and this cell. Like all the cells that are inside the snake array, we need to draw a div on all of those cells, right? Because snake is an array of cells. We need to draw a div at every cell. Can I say that? So what you can do is, you can say snake.forEach. You can go to each snake cell. You can go to each snake cell and try to draw something. So we'll say const element is equals to draw div. In the draw div, what you're going to do? You're going to say snake cell dot x, snake cell dot y, and the class should be snake. And once done, we'll say game arena dot append child element. And the moment you do that, and the moment I click on start game, can you see there is a snake in place as well? This definitely looks nice. This is definitely looking nice, right? Now all we have to do is start moving the snake. But before I start moving the snake, I would like to commit up till here. Added snake UI. Here we go. Now, let's say, if you carefully see, now what's happening is that the snake the snake array, right? It is storing coordinates x1, y1, x2, y2, x3, y3. You can say that this is x1, y1, this point is x2, y2, and this point is x3, y3, and we are keeping the top and the left of our div here, and then drawing a div of 20 pixel width and height. Top and left of the div here, and drawing a div of pixel 20 width and 20 height. Same thing here, and same thing in fact here. This is the coordinate of the food item, and we are drawing a div of 20 pixel width, 20 pixel height, and then just giving it a border radius. Here the border radius is very less. Okay, this is something that we have actually done. And if you take a look at the code, code is pretty simple. We just initiate this game board, we initiate the start button, and things are done. So now what we actually need to do is, we have a dx and a dy value. What dx represents that how much you need to displace in the x-axis, and dy represents how much you need to displace in the y-axis. Very simple thing, right? Dx represents how much you need to displace in the x-axis, how much you need to displace in the y-axis, right? So technically what we can actually do is, we can write a method update snake. That is, before we actually draw the snake, let's update the coordinate of the snake, because it will move and then we will draw. After drawing will move, you can try, but I believe we should first move and then draw. Okay, we should write function update snake. Snake update is going to be very simple. Snake update is going to be absolutely very simple. All we have to do is just calculate the new coordinate that the snake head will go to. First step, calculate new coordinate the snake head will go to. What is the new coordinate the snake head will go to? So const new head is equals to, x-axis will be whatever is the snake's current head dot x-axis, I will add dx to it, and whatever is the current snake's y-axis, I will add dy to it. Right, I will add dy to it, and then I'll say snake dot unshift. What does unshift do? Unshift adds at the front of the array. I'll add the new head, and snake dot pop, remove the last cell, add the new head. Can I say that? Save it. And now if I start the game, can you see the snake is actually moving? But the moment it actually collides with the food item, technically the food item should be gone, right? How can we write that logic? So technically what should happen is that if the new head of the snake dot x-axis is equals to x coordinate is equal to the x coordinate of the food, and new head's y coordinate is equals to the y coordinate of the food, then there is a collision that happened. If a collision happens, then what should we do is, we should increment our score by 5, right? And we should not pop the tail, because now the snake has to grow, right? If you want the snake to grow, then let's not pop the tail. Don't pop the tail, right? Don't pop the tail. And let's do one thing. What should we do? We should move the food. Technically we should move the food. We'll see how we will move the food, but let's see what happens. So technically now if I start the game, right? Both of them are in the same line. The moment they touch it, the score should increment. See, now the score is up. The moment the score is up, we need to change the food item, right? We need to move the food. Okay. The only thing that matters is that wherever you update the food, the new food should not be in those cells where the snake body is. Think about it like this. When you eat the food, the new food should not come in these 4 cells. And can you see the snake is growing also? Can you see my snake grew also? But the new food item should not be immediately where the 4 cells of the snake are, right? So technically we'll write a method move food, and we have to write a logic there. What should be the logic? Function move food will say let new x new y. Okay, and we can write, let's say, a do while loop or any kind of a loop. We'll say do new x, right? We need to get a random value, right? So I'll say math dot floor. Okay, math dot floor of math dot random. Okay, so randomly we are going to select. So the x-axis is going to be selected from what? Whatever is the game arena, right? I guess arena size, not game arena. Arena size minus cell size, right? Divided by cell size multiplied by cell size. And same thing we can do for the y-axis. I'll help you with this formula in a moment, that how this formula is working. But for the timing, just assume that this randomly selects a food item for you. Randomly selects a position for the food item for you. But you will not use this food item if let's say snake dot sum. So there is a method sum, right? I'm not sure if you guys know about the sum method or not. Sum mdn, right? So you can see there is a array dot sum method. It instance test whether at least one element in the array passes the element provided or not, right? So at least even if one of the element passes the condition, then it is going to return a true, right? So we are going to check that if let's say snake cell, right, snake cell dot x-axis is equals to the new x, right, and snake cell dot y-axis is equals to new y. Okay, so in case the new food item location that we detected is equal to the snake's body coordinates, we are going to reinitiate the randomness, right? We will reinitiate the new random food item location. If let's say they again collided with the snake body, we will do it again. We'll keep on doing it till the time we find the first position where the snake was not present. Once done, we are going to update the food as x as new x and y as new y. And that's it. We'll call move food. Save it. Start game. Let's see. So you can see the moment it collides, it will also increment the size of the snake. And can you see the food item moved up? The food item moved up. Let's try again. The score will also increment, you will see. And the moment they go here, you can see the food item moved randomly in some other location. That's what we wanted. So git add all, git commit -m, added snake and food collision with food movement, git push. Right, now you might be thinking, what is this formula all about? What is this formula all about? Okay, and also you can see the snake is going beyond the boundaries. We have to stop that also. But let's come to it. So now let's say this is what? This is the arena size. And this is the cell size. Okay, this is the arena size and this is the cell size. And what do we want? We want a random cell inside this arena, right? We want some random cell inside this arena, and that random cell should not be in the snake body also. right? So that logic though we have written inside the do while loop, but how we are randomly selecting, how we are actually randomly selecting the overall cell. Now you can see this arena size represents the size of this grid where the snake is allowed to move, and the cell size is actually representing this particular cell. Now what happens when you do arena size minus cell size? What happens in this case, right? This is going to actually, let's say, if we talk in terms of the y-axis, this is going to subtract width of one cell from your arena, right? This is going to subtract width of one cell of arena. So let's say there were, let's say 10 cells, it is going to subtract one whole cell out of it, right? Now, why do you want to do that? Because we want to make sure that at any point of time, this coordinate should not be chosen for the cell. Think about it like this. Either you will select, like if I have just, let's say, forget about this much. If we have just this column, either the food item will be on this cell and you will draw 20 pixel, 20 pixel, or food item will be on this cell, you will draw 20 pixel, 20 pixels, or this cell, or this, or this, or this. These lattices are going to be there. But we do not want our food to be on this lattice. If it is on this lattice, it will be drawn outside the grid. Can I say that? It will be drawn outside the grid, right? So that's why we subtracted this particular value, so that any random value that we have generated comes in this range, comes always inside this range, right? Think about it like I'll explain again. So currently in the y-axis, you have this strip. If I select a random value, this random value can come any one of these coordinates, right? I definitely do not want any coordinate from here and below this, because if I get a coordinate here, sorry, I do not want a coordinate here, because the moment I get a coordinate here, it will be a cell outside. I do not want a coordinate here, it will be a cell outside. The last coordinate that I can support is here, because it will be this particular cell. So that's why from the total available y-axis, I subtracted these 20 units, because these 20 units, if I get a random cell here, is going to cause us a problem. That's why I subtracted. I hope this point actually makes sense. Now, after subtraction, I divided by cell size. Now, because as I said, in this region, I can get any random pixel, right? It's not necessary that I will only get these pixels. It's not necessary, right? That I will get only these pixels. I can get any random pixel in between also. So dividing it, what happens is, if let's say we get a random pixel here and we divide it by the pixel size 20, think about it like this. So let's say this is the y coordinate. I say that this is my region and this is the whole arena. Let's say this is 600. So first things first, if I will, and this is, let's say 20. So first things first, what I did, I calculated 600 minus 20. Why 600 minus 20? Because I want a random value in this range only. I don't want a random value in this range, because the moment a random value comes inside this range, this can actually lead up to make it go beyond the grid. Okay, because the grid is just up till here. Cool. Now I'm going to select a random value here, but any random value that select will be any cell, right? It can be this, anything. But if I divide it with 20, then let's see what happens. If let's say you have any coordinate here, if you have any coordinate, or let's start with this. If let's say you have any coordinate here, so let's say you randomly got 31. So if you do 31 by 20, that's going to be what, 1? Can I say that? Because we are doing mat.flow, right? So it's kind of like this is the first unit, and up till 40, whatever value you get, if you divide by 20, you will get 1. Now let's say you got 42. If you divide 42 by 20, you will get 2. That means we are referring to coordinate number 2. So this is kind of like coordinate number 1, 2, 3, and so on. That's why we divided it with 20. Right? Cool. Now, once this division, and this is for uniform division, so that we get a uniform division altogether. Right? So this is going to divide our adjusted game size by one of the cell size. And the result is the number of possible positions for placing the food along one axis. And I explained with y-axis, same thing is going to happen with the x-axis also. right? Cool. Then whatever is this value, whatever is this particular value, this minus this by this, okay? I then divide it, I then multiply it with 20 also, right? Why we are multiplying with 20? Because here I will get 1 or 2 or 3 or 4, but actually this is not 1, right? This is 20 pixel. This is sorry, this is, let's say, 10 pixel, 20 pixel, 30 pixel, 40 pixel. These are actual pixel values, right? So let's say if we get a value like 3, so we have to multiply it with 20 to make it go to 60 pixels. That we are actually referring to the 60 pixel. The position at the 60 pixel is the third position for us, and so on. So that is what we have actually done inside this particular formula. And then we just multiply it with random so that we randomly get a value and just calculate the floor out of it. That's how you can actually calculate the new food item. Currently in the game, if you see, when you start the game, the snake goes to the food, eats the food, increases its size, but it will keep on going. Like it will go outside the wall also. That's problematic. Right, you can see 1, 2, 3, and now it will cross the wall. It will cross the wall. That's a bit bad. So what we can do is, this is the position of game over, right? At this point, the game will be over. You don't need to run the game beyond. This will be your game over, right? That's what we are going to do. So before we actually start the interval, right, we will check for, let's say, or not here, we'll check for game over. Okay, we'll check for game over. So let's write a function is game over. Now how do you detect whether the game is over or not? If the snake hits the left wall, right wall, top wall, or bottom wall, any of the walls, if the snake hits, the game is gone. And apart from that, if the head of the snake hits itself, like the snake itself hits the body, then also the game is over. So first of all, check snake body. Check snake body hit. So how do you check the snake body hit? So let's do one thing, right? So I'll say I is equals to 1, I less than snake dot length, I plus plus, right? We are going to check if the head of the snake, that is snake of 0 dot x, is equals to snake of I dot x, and head y coordinate is equals to y coordinate of any other cell, then we return a true, that yes, game is over. Game over, right? Otherwise, check wall collision. We are going to check for wall collision. How do you check for wall collision? So we are going to check const is hitting left wall. How do you check whether you are hitting the left wall or not? If the x-axis of the snake, x coordinate of the snake becomes less than 0, that means you are hitting the left wall. Okay. How do you check if you are hitting the top wall? If the y coordinate of the snake becomes less than 0, then you are hitting the top wall, right? How do you know if you are hitting the right wall? If the x coordinate of the snake is greater than or equal to game size, game arena size, or arena size, then, and same thing, down wall. That if the y-axis becomes greater than the game size. If any of these conditions is true, we are going to return true. So return is hitting down wall, or is hitting left wall, or is hitting right wall, or is hitting top wall. If any of the walls is hitting, then also the game is over. I'll say game over. So I'll say if is game over. So if the game is over, what we are going to do? We can say alert game over, score is equals to score. Okay, and the moment alert is clicked, we'll say document dot reload. Okay, we are going to reload the document and return, and not document dot reload, document dot location dot reload. Save it, and now if I start the game, I will eat this food item. Okay, you can see food items bumped somewhere else, size of the snake increased, and let's wait for wall hitting. You can see the wall hit us, the game is over, score is 5. If I click on OK, oh sorry, my bad, this should be return, not return L. Okay, so that method was not returning. Let's just quickly see. We can make the game a bit fast also, just for our debugging purpose. Let's say in 500 milliseconds we will refresh. So now the snake, you can see, is a bit fast. Okay, and the moment snake hits the wall, you can see game over. Okay, and we are going to refresh, right? Okay, some issue why it's not refreshing. Should we give a callback to alert? I guess I know the problem. The problem most probably is that, let's see, we are having a set interval, right? Oh, one second. This should be window.location.reload. Is that? Let's inspect window.location. Yep, I guess location.reload. Yep, it should be window.location.reload. Yep. So start game. Let's see. No, there is some other issue. Okay. Why this might not be breaking? So here we have a game state, right? That whether the game has started or not. So currently what's happening is, why again and again it's showing an alert, because this interval is is getting updated again and again. Like new interval is coming up, new interval is coming. So the moment we see that the game is over, what we should do is we have a variable game started. That game started variable should go to false. And before we actually start an interval callback, we should check if the game is not yet started or the game started is false. There is no point of checking game over and putting all of these checks here and there. The moment I save it, start game, and collided, good, size increased, and here we go. You can see alert coming up. If I click on OK, you can see everything just got reset. This is working like a charm. Added game over logic. Here we go. Now the only thing left in the code is how to move the snake on our arrow key directions. Now you know that move snake function is already there in the draw. If I go here, update snake, this one. If I correctly update the dx and dy, we can automatically move the snake, right? So what should technically happen is that if somebody presses the up arrow key, then what should happen is dx should not change, right? If the up arrow key is pressed, dx should not change. And what we need to set up the value of dx so that there is no change, technically we should make dx is equals to 0, because if we are moving in up direction, then x axis will not change, only y axis will change. So dx should become 0. And the value of dy should become kind of like -20. But if somebody press the down key, right, then also dx should be 0, but then dy should be +20, right? If somebody press the left key, then you have to just move in the left direction in the same y-axis. So dy should be 0, but dx should be -20. And if somebody press the right key, then again dy should be 0, but dx should be like +20. And this is our default direction also. When the game starts, it's already in the right direction, and you can remember dx was +20, right? Dx was +20. So I can even show you. For example, let's say instead of cell size, if I do minus cell size, start the game, right? You can see it was kind of like going to move in this direction, right? Or let's say if I do dx as this, and let's say dy also as cell size, let's do something like this. And if I click on start game, can you see snake moves in a horizontal direction? Why horizontal? Because x is also moving, y is also moving, right? But technically for our case, x and y both should not move, right? So this is what we are going to play with. This is what we are going to actually play with. So we are going to add a bunch of event listeners inside our, you can say keys. You can add a event listener altogether, and then actually decide what should be the change in direction that should technically happen, right? Cool. So what we should technically do is here, before we start the game also, we should also check if game has already started, or let's say if the game is not started, then only we should run the game. And before we actually run the game, we should say document.add event listener key press. Okay, change direction. We are going to write a method change direction. Okay, what should happen on the change direction? So this is an event, change direction is an event, so we will get access to the event object, e object, and from this event object we can actually check which key did we press. Which key did we press? We can very easily check that. Okay, so technically you can say that const key pressed is equals to e dot key code. So there is a method called as key code. This key code property actually tells which key is pressed. So inside our keyboard, every key has a unique number. So for example, the left arrow key has a number 37, right? Then the right arrow key has a number 39. Up arrow key has a number 38. And down arrow key has a number, I guess, 40. Okay, so you can actually check the key codes. Key code in DOM. Sorry. Key code in DOM. Okay. You can actually check the key codes in the DOM. So or I would say key code in DOM list. See, these are the key codes. If you see up arrow, left arrow, down arrow key, these are the key codes 37, 38, 39, 40. Okay, so whenever we hit the key press event, that means when we are on the DOM and any keyboard key is pressed, any key if you press, it will call this function. Then whatever key I pressed, I will get the key code and I will match. If the key code is one of these key codes, then we are going to change the direction. Okay, cool. So we are going to say that if key pressed is equals to left key, if key pressed is equals to right key, if key pressed is equals to up key, if key pressed is equals to down key. What should happen if you have a left key, right? then technically if you press the left key, then dy should remain what, 0, and dx should go minus of cell size, right? If you press the right key, then dy still should remain 0, dx should go cell size. If you press up key, then dy should go minus cell size, dx should go 0, and vice versa here. But there is just one catch. There is just one catch. What is that catch? Think about it like this. If you are going in an upward direction and I press the down key, then nothing should happen. If you are going in the upward direction, I can go left or right. I cannot immediately come down. Can I say that? If you are going in upward direction, I can only go left or right. Right? Think about it like this. If my snake is going to the right, how can I immediately move it left? I can move it down or up. Right? So you can say that if you want to go left, then the snake should not be going right. If we want to go right, the snake should not be going left. If we want to go up, the snake should not be going down, because if you are going down, you cannot go immediately up. You can go left or right only. So this is something that you have to always check, right? So you can say, let's say const is going up. How can you check whether you are going up or not? If the value of dy is equals to minus cell size, that means you are going up. Is going down. If the value of dy is plus cell size, that means you are going down. Is going left. If the value of dx is minus cell size, you are going left. Is going right. If the value of dx is plus cell size, you are going right. And here we should put a check that we should not be going right, then we can go left. We should not be going left, then we can go right. And we should not be going down, then we can go up. And we should not be going up if we want to go down. And that's it. So technically, if now I run the game, okay, 1 second. So let's do one thing. Let's see if the event is getting triggered or not. I'm pressing the key, nothing happened. Console.log e comma e.keycode. Inspect console, clear, start game. Okay, it's not detecting the change in the event. Okay, so what happened is, I guess key press has a capital P. No. Let's see why the key press didn't work. Oh, I guess key press, I guess somewhere I read that key press has been deprecated or what. Right. I guess key press has been deprecated. Key press. Yeah, this has been deprecated, right? So we should use key down in the instead. Let's try to use key down. Save it. Start game. Yeah, key down is working. So now we write, we go up. Okay, we go left. We go down. Okay, this time it didn't detect. Let's see what happened. Okay, now it's not detecting. What happened? Now the food collision is not getting detected after the first collision. Let's see why. So we go to game loop. Okay. And update snake. Let's see if update snake is getting called. Console.log update snake called. Okay. Inspect. Okay. Console. Okay, update snake is getting called. We got a keyboard event. Update snake still getting called. Update snake still getting called. And I went left. Update snake is getting called. It's not detecting the collision. Strange. And score also didn't get updated, right? Let's try to solve the bug. So very small issue that we have in the code is that, first of all, this whole fraction that I talked about should be computed, and then we should actually scale it to the pixel level, right? So this multiplication should happen outside. Same thing here. This multiplication should happen outside, because first of all, we'll get that fraction and convert. First of all, we get a random value, then correspondingly get the fraction. We'll round off the fraction, and then we'll scale it up to the pixel size. If now you actually start the game, right? And now if you go here, if you go back, now you can see they are aligned also. Previously they were not looking aligned, and now you can see the snake size increased as well. I want to increase the speed of the game. I don't want it to make boring. Let's make it 200. Now it's a bit fast. Yeah, now a bit better. Right, you can see, and snake is increasing in size and something like this. Very nice. Just last round I'll play. And in fact, like, if you actually know the actual snake game, what happens is, if you keep on increasing, the speed of the game also keeps on decrease. Like the speed of the game also moves kind of like in the increasing pace, right? So what you can do is, let's say we have a variable, let game speed. Let's say we initialize the game speed with 200. And every time, let's say we do game speed minus equal to 5, or let's say minus equal to 10, and we should only do it if game speed is greater than 30. We will never go game speed less than 30, right? And let's say the interval that we have here, no, let's make intervals go with game speed. Let's try now. I believe this should now look good. Okay, so after some time, I believe the snake should start moving a bit more faster. Okay. Let's decrease the game speed by more margin. Then only I guess we'll come to know very fast. So let's say we'll decrease it by 50 every time. Initially, what is the game speed? It's 200. Okay, and this is the interval, right? This is the interval. This looks good. Now if I refresh, not moving that much, right? Let's console.log game speed. Do we have change in the game speed? Game speed, inspect, console. Cool. Let's see, game speed is 200. Yeah, game speed is now what, 38? No, that's the key code, right? Game speed is not changing, I guess. Let's see. Oh, I guess I got the issue, I believe. I guess I got the issue. So technically, this is taking reference from the global variable, right? And game loop has been called only once. Yeah, oh, that's not how we can actually change it. So technically what should happen is, yeah, we need to start every time a new, and if the game speed changes, no, then we have to call the game loop once, like separately again. We cannot rely on this interval, or because of the fact that this game speed is having that particular value in this its closure, right? That's why it never gets called again. And in fact, if you call console.log game speed here, okay, you can see game speed is all 200. It's 150. 1 second. It's 100. So game speed is decreasing, but the interval value, this value is not going to come up within this callback function, right? This value, if you print outside, is always 200. Console.log game speed. Okay. Game speed. This is always 200. So if you refresh, then you will realize that you can see one value went 150, one value is still 200, right? That value is still 200 and it never gets printed again as well. That never gets printed again as well. So let's think what can we do here. So what we can do is, if you want to increase the speed of the game, what do we need to do is, we need to change this game speed variable, and this gets allocated once we start the interval. What we can actually do is, we can clear the interval. We can actually clear the interval, right? If we collide with a corresponding, let's say, food item. So we'll say clear interval, we'll say interval ID. Game speed I'm going to decrease with a value of, let's say, 10 units every time I'll decrease. And this interval ID I'll make kind of like a global variable. If I save it, now what will happen is, currently the same interval is going, but the moment you eat the food, okay, 1 second, it stopped. It stopped because now what happened is, see, you cleared the interval. If you clear the interval, there is no loop, that game loop going again and again. This is the game loop. No game loop is going again and again, right? So technically what you should do is, you should clear the interval and call this method game loop again, right? Game loop you should be calling again. Save it. And now if you refresh, now you can see, now a new interval actually started, and the speed of your snake is also changing a bit, right? So after a few eats, you will realize the snake is going too fast. Like after 3-4 more eats, I believe the snake will go very fast. Now you can see it's becoming faster now. Then see, I can see significant change in the speed. Now you can see it's more smooth as well. Ooh, now very fast. Yep, now though extremely fast. Yeah, so game over, score 75. So this looks good. I believe we are in a very, very good shape with our app. Completed game logic with game speed. Here we go.